Hey Chem Kids, Campbell here. To watch this video, you're going to need your gold nomenclature packet. Turn to page 5 where it says special ionic nomenclature up at the top. And you're going to need your periodic table because we're going to learn about the rules for special ionic nomenclature. Now, last unit we learned regular ionic nomenclature. So what's special? Well, if you remember on our periodic tables, right, we put charges on top of some columns. Like this was +1, this was +2, we had a +3 here, and then -3, -2, -1. But we didn't put any charges on top of our transition elements or anything here. And the reason for that is these guys could be different charges. See, iron could be +2 or +3. Copper could be +1 or +2. So I like to say that these guys have a little bit of an identity crisis because they could be a different charge. So, and that's really important actually to its identity, is what the charge is. So when we name it, we have to use the information we have to designate what the charge is. And we're going to do that using a Roman numeral. Now, there are two elements we don't have to do this with, and that's silver and zinc. Zinc always happens to be +2, and notice that that's a Roman numeral 2. That doesn't apply to mercury, because mercury could be +1 or +2. And silver here always happens to be +1, and notice that's Roman numeral 1, and it always is +1. That doesn't apply to copper, because copper could be +1 or +2. So let's learn how to name these, because it's very important that we specify the charge the metal has when we write its name. Now, what do I mean specify the charge? So what we're going to do is use a Roman numeral to indicate what the charge of the element is. It's not how many you have, because if you look at copper here, this is copper 2 sulfide. It's not that we have 2 coppers, but it's, remember, sulfur has a charge of -2, and so if I only have 1 copper and 1 sulfur, that means this must be copper +2, right? If they have the same charge, they cancel and we don't have the little crisscross numbers. So this happens to be copper 2 sulfide. So this means that copper is +2. In this case here, if I have 2 coppers, and I know that sulfur is -2, sulfur does not have an identity crisis, that means copper must be +1, because +1 times 2 is +2, and that if you add that to a -2, that's 0, right? The charges have to add to 0. So this is actually called copper 1 sulfide. So we're going to use Roman numerals to designate the charge, which gives us a little bit more complication to when we're naming stuff. So let's get to what the rules are for naming. So rule number 1, just like with ionic nomenclature, name the first thing, no change. So whatever it is, name it. If it's an element or a polyatomic ion, find it on your periodic table, write down the name the way it appears. Now, this is a little different. We're going to put some parentheses right after that name, and that's where we're going to put in our Roman numeral. But we're not going to do the Roman numeral until we finish getting all the name stuff done. Rule number 3, just like ionic nomenclature, name the second thing. If it's an element, change the ending to IDE. But if it's a polyatomic ion, just flip to the back of your periodic table and write down the name of that. So name the first thing, put in parentheses, name the second thing. If it's an element, change the ending to IDE. Just like we do with ionic nomenclature, only difference here is we're going to put those parentheses in. Now, what goes in the parentheses? That's the Roman numeral. Remember, the Roman numeral represents the charge on that element, that first element, the metal. So this is the equation. Write this equation down, and then I'm going to explain it. #1 times X plus #2 times the charge on the second equals 0. So write it down, and let's talk about what this means. So the little hashtags, when I was younger, it wasn't a hashtag, it was called the number sign. So what that hashtag means is how many of that element there are. So that's the subscript. I don't know why there's a little closed parentheses here, but so hashtag is how many of the element are. So #1 is how many of the first element you have in that formula. #2 then represents how many of that second element or polyatomic ion you have. X is going to be the Roman numeral. We're going to solve for X just like you do in a math equation. And, oops, head's in the way here. The charge on the second, this right here, that is the charge of the second element or polyatomic ion that's on the periodic table, because the second element, it's always a nonmetal. Nonmetals have known charges, right? -3, -2, -1. And polyatomic ions, right, they also have known charges. So we always know the charge of the second thing, and we're going to use that to figure out the charge on the first. All right, so #1 times x plus #2 times the charge of the second from the periodic table equals 0. And then we just got to do some math. So now, one thing, silver and zinc don't need a Roman numeral, because remember, silver is always +1. It's in that Roman numeral 1 column. Zinc is always +2 because it's in the Roman numeral 2 column. If you put a Roman numeral down, I won't freak out, but you'll notice when you go to name, there won't be a Roman numeral there. Or sorry, when you go to write the formula. All right, so let's see how this works. Okay, name the first thing, Pb, that's lead. So we're going to write down lead. We're going to put in our parentheses for our Roman numeral. This is the element chlorine. So remember, if it's an element, you change the ending to IDE. So this is going to be chloride. So those parts are very similar to what we did on our last one, but now we have to figure out what goes in here. Okay, so my equation, #1 times x plus #2 times the charge of the second equals 0. All right. So #1 is how many we have the first. If there's no number here, that means it's 1. So this is going to be 1x plus #2, how many we have of the second. That's what that 4 stands for. So that's going to be 4 times the charge of the second from the periodic table. So we go to the periodic table and we go find chlorine, and we see that chlorine is -1. We set that equal to 0, and now we just solve for x. So 1x, which is just the same as x, plus 4 times -1, 4 times -1, right, that's -4 equals 0. So x is equal to 4, right? Add 4 to both sides, and we get x is equal to 4. So this is Roman numeral 4, which is IV. That's how that works. All right, next one. We got Fe, which is iron. We're going to put in our parentheses. This is the element oxygen. So remember, we chop off the N and we put IDE. So this is going to be oxide. All right. Now we got to figure out our Roman numeral. Okay, how many we have of the first? 1x. How many plus how many we have of the second? There's no number here, so that just means 1 times the charge of oxygen from the periodic table. Oxygen is right there. It's a -2. And that equals 0. All right, so 1x minus 2, right? 1 times -2 is -2 equals 0. So that means x is equal to 2. So that means this is Roman numeral 2. Now, this is silver. Remember I said silver doesn't need a Roman numeral? You could put one in there if you want. You don't have to. We could just name this silver. This is iodine, so we're going to change the ending to IDE. So this is silver iodide. All right. Now let's try some with polyatomic ions. All right, this is iron. We put in our spot for our Roman numeral. This is the polyatomic ion sulfate, so don't change the wording of the polyatomic ion. And now we got to do our little equation. All right, let me move my head down here. Okay, so this time I have 2 of the first one, so it's going to be 2x plus I have 3, not 4. It's there. You only have more than one polyatomic ion if there is a parentheses with a number outside. So this is 3 times the charge of sulfate from the periodic table. So we go find sulfate. We see that's a -2. That equals 0. All right. So we got 2x plus 3 times a -2, right? Well, that would be -6. So let's just write -6 equals 0. All right, we got to add 6 to both sides. We get 2x is equal to 6. Divide both sides by 2, and we get that x equals 3. So this is 1, 2, 3. Boom. Iron 3 sulfate. All right, one more. That's Cu. That's copper. Name the first one. Put in the Roman numeral, or actually put in the parentheses Roman numeral. This is nitrate. So from the back of our periodic table. All right, we only have one copper, so it's 1x plus, there's 2 nitrates. Charge of nitrate from the back of your periodic table is -1. That equals 0. So we have 1x minus 2 equals 0. So that means that x is going to equal 2. So that's going to be Roman numeral 2. All right. Just take some practice. You got to remember that formula. All right, let's talk about writing formulas. Now, writing the formulas from names is just like regular ionic nomenclature, but instead of using the periodic table to find the charge of the first element, that's our Roman numeral. So you only have to find the charge of the second one to do your little crisscross. All right, so let's take a look. Copper is Cu. We write the symbols just like we did before. Chloride, because it ends in "ide," that means it's the element chlorine, Cl. This means that copper is +2. We go to the periodic table to find chlorine. We see that's -2, and we do our little crisscross. And remember, we don't write the 1, so this is just CuCl2. Lead sulfate, lead 2 sulfate, that's Pb. Sulfate, notice it ends in 8. That means we got to go to the back of our periodic table and find it. Sulfate is SO4. Lead is +2. That's what this means. That's the charge on lead. Sulfate on the back is -2. Notice they have the same charge. That means they equal 0. So that means we don't have to do any sort of crisscross. So you just write PbSO4. All right, last one here. Tin 4 sulfite. So tin is Sn. I like to say it's a sin not to remember tin. Sulfite, ite, right, means it's a polyatomic ion, which is SO3. Now, tin is +4. +4, that means, right, that's the Roman numeral 4. Sulfite on the back of the periodic table is -2. So we're going to do a little crisscross. So that means we have 2 tins, and then we have 4 sulfites. So SO3, you got to put the parentheses around it because we don't want to have 34 sulfites. We want 4 of these sulfites, which is SO3. Now, there's one little trick when you crisscross. When you crisscross, if they can be reduced, you got to reduce them. So notice that 4 is a multiple of 2. That means we need to divide both of these by 2. This is the one downside to the crisscross method, is if they can be reduced, you have to reduce them. So the actual formula here is Sn, 2 divided by 2 is just 1. We don't write a 1. SO3, we got to put that in parentheses because 4 divided by 2 is 2. So that's the final answer there. So if you have multiples, it's the same thing like if we had the 2 and the 2 here, we would have to divide by 2 because we got to reduce. You got to go to the lowest, and you don't divide the 4 because the formula for sulfate is 4. Just like we don't divide this 3 because that is the formula of sulfite. So don't change the formula of polyatomic ion when you are crisscrossing or when you're reducing. All right, so do some practice. Ask me if you have questions, and let's do some special ionic nomenclature. So next page in your gold packet. Get to work.